Welcome everyone. If you can let me know if you can hear me. Welcome. If you can just let me know in the chat if you can hear me, and then we'll start the session tonight for the Q&A. Oh, great. Excellent. Thank you. So I'm going to share my screen. And again, if you just let me know if you can see it, then we can start. The Q&A is live. So while we're going through, if you have any questions or if you have any questions beforehand already, you can already put them into the Q&A and I'll answer those as we go through. Okay. I'm just going to put this on presenter. Okay, so welcome everyone to the Process Safety Forum. For anyone who hasn't been to the Process Safety Forum, just a quick reminder that this session is being streamed live to YouTube, and it will be available for playback. So just be mindful of what you say, because obviously others will see it afterwards. And then I'm just going to give you a quick introduction to what the Process Safety Forum is. It's a place to get access to industrial experts. So that's both myself and then others on the line who have good practice, particularly tonight for risk management. It's the first Wednesday of every month at 8 o'clock in the UK time. It's available for catch up on YouTube and it's supported by masterclasses. So this month we had our masterclass on the 17th of February. And it's a place to share best practices and for all of us to learn. So quite often I learn from your guys' practices in these sessions. So thank you again for sharing what you do on the sessions. So this month we're looking at risk management. We're looking at hazard identification, risk assessment, and then how to manage those afterwards. This is one of the key elements from the process safety management frameworks that we discussed last month. So how will this session work? So as the sessions always do, we'll use 10 minutes at the beginning of the session to give a quick introduction to the topic and to the presenters. And then I'm going to open the floor for questions, and then I'll wrap up the last 5 minutes of the call to tell you what's coming up next. Okay. So introduction. For those of you who don't know me or haven't attended the Process Safety Forum before, my name's Louise Whiting. I have over 11 years experience in 2 major operators, BP and Shell, and I run these sessions as a volunteer to allow people who potentially don't have the same experiences as I do to have access to people who they can just ask advice from. And then also for others who wish to share their experience to come along and share that experience with us so that we can all learn and improve process safety together. So the types of risk management that we might have. So I've just given a quick list here. There's probably loads more different types of risk management that you guys might use, but we have management of change process. So once we identify a change, one of the key components for management of change is risk assessment and then managing that risk through execution and then into the operate phase. We have something called operational risk assessments. So if you're operating your facility and you find that something has broken or there's a deviation from what you thought you were going to operate, you would raise something called an operational risk assessment, which is a temporary risk assessment, which will either allow you to continue to operate or it will call for you to shut down. We have the lockout tagout register. So again, that's a way of managing our risks to make sure that what we said, the position of those valves or the way in which we're going to use an inhibit, that's going to remain. And so we have the lockout tagout register as a way of managing our risks. We have our permit to work system, including isolation certificates, mechanical completion certificates. We have startup and commissioning procedures. So these are trying to reduce the number of problems that we have once we have the hazardous fluid within our system. And so they're a great means for managing risk in our facility. We also have access control. And access control can form 2 functions. The first can make sure that people are not located in a location where there's a hazard potential. And then the second one is to make sure that people who are not competent to be in a certain location are not present there, i.e. they're not putting themselves in harm's way or putting others in harm's way by being in an area where they could make a mistake. We have barriers. So we use barriers both for lifting, but we can also use barriers, for example, when we're pressure testing equipment, or if we are doing other high hazard activities like nitrogen purging, etc., we may put barriers in place. And then we also have process monitoring. So through process monitoring, we should be able to identify the different things which are happening on our facility and how when they are deviating from what we expect, and we can then manage the risk associated with that. Now, to allow us to manage the risk, we need to identify the hazard, and we're going to be covering hazard in a couple of months. We need to then do a risk assessment, and so we've done layers of protection analysis a couple of months ago, and so we have a little bit of an idea of what risk assessment means, assessing the likelihood, etc. And then once we've done those two, we then need to manage the risk going forward. But it is very difficult to manage a risk if you don't know that the risk exists. So I'm just going to go through a couple of types of risk assessment used in the risk management. So Hazop and Hazard are very common hazard identification tools. Hazop is typical for processes, so either sequential processes, batch reactions, procedures, etc., or processes, for example, your actual process where a fluid flows from A to B within some containment. Your hazard identification is a bit more generic, and you can tailor the questions that you ask to be specific for different types of hazards. So, for example, you can do a construction hazard, you can do a diving hazard, and they can take the form of a what if questions. So instead of looking at the consequence of this, the top event, we could then start to ask ourselves, what if we got loss of containment here? What if, yeah, so that's another way of looking at hazard, and it's also sometimes called a what if study, but you can use that as a hazard. We have a dropped objects assessment. So if we're working over live equipment, so that's either topsides or subsea, we might do something called a dropped objects assessment. And there we're really trying to identify which pieces of equipment we could drop on, and then the risk associated with dropping on those. We have occupied buildings assessment, and this has become a lot more common since the 2005 Texas City incident. But an occupied buildings assessment has a look at where it's safe. It's assessing the risk for people who will be placed in a building. We have quantitative risk assessment. So we're now looking a little bit more at number crunching and having a look at, well, we have this type of incident. These are the number of different initiators we could have. The likelihood of those happening is X. We sum those all up, and then the consequences of it happening and the likelihood somebody will die or will have environmental damage. We have layers of protection analysis, which we've already mentioned, which we had a process safety forum and a masterclass on a couple of months ago. We have hazardous area classification, which is a really great way of assessing the risk. So it's a structured way. You follow a specific standard, you identify the hazards associated with that location, and then it gives you very strict guidance about how to manage the hazards in that location. We have bow ties. So bow ties are generally not used as a hazard identification tool, but they can be really handy for visualization and can therefore help you manage the risk going forward. You have task-based risk assessment. Task-based risk assessment can cover both process hazards as well as typical occupational hazards. And these are the risk assessments that you do when you take your permits out or you implement an isolation. And then the last one I've got on the list, although I'm sure that there are many others, is an override risk assessment or an operational risk assessment, which I mentioned in the first one. That's where you're having a deviation. For example, you need to do maintenance on a specific valve, and so therefore you're going to do a partial stroke test. If that's not part of your normal procedure, you may want to do an override assessment or operational risk assessment, especially if you have to override a safeguard there. Okay, so that's all I've got today, and it takes us to about that takes us to the end of, sorry, I've just lost my screen. Okay. Yes, it's come back. I don't know what happened, so apologize there. So I still have you guys on the line. Great. So if you guys have any questions, please pop them in the Q&A and I'll answer them as we go. I have a comment, is a pre-startup safety review process listed under this category? So a pre-startup safety review or an FSA 4 is definitely, sorry, an FSA 3 is definitely something which is part of your risk management. Yeah, so this is, you've already identified your risk, you've already identified how you're going to manage it, and now as this pre-startup safety review or as your FSA, your functional safety assessment or audit, that you are going to be checking that what you said you were going to put in place is actually in place. And yes, this definitely forms part of your hazard management. And that sometimes what I mentioned about the mechanical completion certificates, etc., that can form part of your pre-startup safety review as evidence for that. Okay. Does anybody else have any other questions? One of the typical questions I get is, you know, when I'm doing a management of change, people just come to me and say, do we need a Hazop? And then I say, well, no, you don't need a Hazop. And people often start walking away thinking that they don't need to do any risk assessment because they don't need to do a Hazop. There are many different types of risk assessment methodology, which I've shown a couple here. And just because you don't need to do a Hazop doesn't mean you shouldn't be managing the risk associated with the change. A lot of people also ask the question, when should I Hazop? There are many different types of Hazop that you can do. You can do a Hazop, a course Hazop, which is in the early parts of your design. And what I would recommend there is to do that Hazop as early as possible when you have the right information available. But when your design is still sufficiently fluid that you can make changes as a result of that Hazop. Then you do it like a course design Hazop. And this is maybe sometimes called your feed Hazop. So you have PNIDs, but you don't actually specifically know which instrument you're going to purchase, etc., because you haven't done that part. And this is to check that your design is okay before you then go and start spending money on it. Again, what I would say is make sure that the design is sufficiently mature, that you're not going to get too many actions out of this one. The first one that you did, the course Hazop, it's fine to get lots of actions out of that. But this second one, you really want to be trying to minimize actions and reduce the amount of change. So once you've done this Hazop, that is when your point of no change starts. And then you start to get into the more detailed Hazop, which is the final one. And then obviously you have Hazops during your operational phases. Okay, I've had a question on the Q&A. So how do we best identify which or how many of these assessments are necessary for a project? So this is a great question. There are, it's often a very big point of debate. Which assessment do I need? How many do I need? How long should they be? Who should attend? All of those are very big questions that projects will ask because all of those things mean money. The more attendees means the more money you spend because you're paying all those engineers to be in a room. The more assessments you need, the more facilitators, the more reports, etc. My guidance is that you really need to be thinking about the hazards associated with the project or operation that you are busy on. So for example, if you are doing a subsea tieback from a well, what I would recommend is that you do a Hazop. Now, if you already have a Hazop for a very similar tieback from another facility or to that facility, then you may then do a Hazop by difference. So it won't be a very in-depth study and you won't need that many people to attend. However, I would strongly recommend that you do a hazard identification study. During this, you might identify things like diving. Then you'll need a diving risk assessment. You might identify things like potential for dropped objects. Then you might need a dropped objects assessment. through that, you will identify the potential for the process hazards, which identifies the potential for the Hazop. From the Hazop, you might identify some high severity consequences and therefore identify the requirement for a LOPA. So if you have somebody who's experienced, they should be able to identify these studies before they happen. But if not, what I would do is I would err on the side of caution and say, okay, guys, let's get together as part of the hazard and have a look at the system and say, which studies do we need after the hazard? All right, that's the best time to be looking. If you're not that experienced on the different types of studies, you do your hazard and then you identify, okay, well, these are the big hazards. How am I going to look at these a little bit more detail, make sure that I'm managing these well? And then you can start to look at your suite of risk assessment or risk management tools. And that's where you'll start to be able to identify what you need to do next. I hope that answered your question well. Okay, so I've got another question. For a node markup on PNIDs, what basis for starting point and end point for nodes? So typically, when you mark up nodes, every facilitator will have a different take on where the node starts and where the node ends. However, what you're trying to do is you're trying to keep one function within the node. If you're doing a course Hazop, that very first stage Hazop, your node might be really quite large and it might cover several PNIDs or might be several items on the PFD. When you're coming to the more detailed Hazop, you're looking really at trying to keep one specific function. So for example, if you're trying to transfer liquid from vessel 1 to vessel 2, you might do the level or the liquid part of vessel 1 with the pump or the level control valve, and then the inlet for vessel 2. Then for the vessel 2, you would think, okay, well, I'm transferring liquid from vessel 2 to something else. Again, you would look at the level there, and then however you're transferring that into the next vessel, and so on and so on. So that's how best to have a look at nodes is you're trying to look at functional intent. The other thing to do for nodes is to make sure that you mark everything. So drains, vents, instrumentation, make sure that you consider everything in at least one node, because you don't want to be leaving some parts of your system unhazopped. There have been many incidents where, for example, cooling systems or heating systems were not considered because those were utilities or vendor packages, and so as a result, hazops were not completed on those, and then incidents occurred afterwards. I've worked on facilities where we've had vendor systems, and because it was a relatively minor vendor system, it was not included in the Hazop, but actually resulted in quite a serious incident afterwards. So really understanding what your vendor system does for you, what the risk is of it not performing that task, or what could go wrong. Sometimes you can't think that without doing the Hazop. So keeping the Hazop into design intent, like the design intent for that node, and then making sure you definitely cover the vendor Hazops is really key. Okay, I've got another question here. Is Hazop process, can we say, semi-quantitative, or is it only a qualitative process? So this is a great question, and it's something that I answered in the LOPA workshop. I recommend that you do not do any risk assessment in the Hazop. The intent of the Hazop is to identify hazards. So you are using it as a hazard identification tool, and you're using it in a very structured way to identify hazards associated with your process. Now, if you start to muddy the waters by introducing risk assessment as well into this hazard identification process, one of two things can happen. One is you guys get so worked up about the risk assessment, the color, which block it's in, whether it's green, red, yellow, purple, blue, whatever your colors are. You get so focused on that, you actually forget the intent of the workshop, which is to identify hazards, identify the safeguards, and determine if those are sufficient to raise a recommendation. What can often happen when you introduce risk assessment is people are so worried about the number of red risks that you're raising, etc., etc. They just want to do a risk management in that session to try and minimize the number of reds. That is really detracting from what you are trying to do in the Hazop, and therefore you can result in a substandard Hazop if you do risk assessment. The other thing that can happen is you wholly underestimate the risk associated with high severity consequences. The nature of the high severity consequences is that they are very infrequent events, typically, and they typically don't happen several times at the same location unless you have some inherent problem with that type of equipment. And so therefore, by the nature of that, the people who are attending around the room are very unlikely to have seen that type of hazard being realized at their facility. But that doesn't mean that they are that their experience is representative of how typical this is in the industry. Okay, so for example, has everybody seen a seal leak which has resulted in a mist forming and an explosion? No, most people haven't seen that. But doesn't mean that it's never happened, and it's never happened in the industry, or it's never happened at your type of facility. So really looking at the likelihood in the Hazop is not a very good idea, because the people in the Hazop, to try and think of these complex problems and identify the likelihood of those complex problems without breaking them down into smaller steps, it's just asking for disaster, because you're going to underestimate the risk. Okay, so really separate the hazard identification, keep that in the Hazop, and then use your LOPA as your semi-quantitative risk assessment. Or if you want something more qualitative, take it into a quantitative risk assessment, a QRA. So keep your Hazop just for identification, and then move those high severity risks either to the LOPA for the semi-quantitative, or move them over to the QRA for the quantitative risk assessment. I hope that helps. There's a follow-on question for that. So if you do decide to do risk ranking in the Hazop, I strongly suggest you don't. But what I would say is make sure that you get the consequences right, consequences without safeguards. So you make sure that the severity of your consequences are accurate as to what the worst case is for that scenario. And by doing that, you make sure that the follow-on processes, which are based only on consequence assessment, will happen even if you underestimate the risk in the Hazop. You would need to typically use your risk matrix tool, whatever your risk matrix is for your facility. And, you know, so it really depends on what you're assessing, how your risk matrix looks, and whether you're going to be doing risk assessment before safeguards or after safeguards. But again, I would strongly recommend you don't do this in the Hazop. It takes away from the quality of the Hazop. Do this outside the Hazop, in the LOPA, the QRA, and then for those low severity consequences, you can just draw a team together, or you can stay together after the Hazop. So I've got a question here from Ramesh. Is the safety case not one of the assessments? So the safety case is the ultimate document which you use to manage risks. The safety case is not typically an assessment tool itself. The safety case collates all of your data about risk management, risk assessment, hazard identification. It collates that all into one place to say, this is how we manage risk here. One of the appendices for your safety case may be an LOPA demonstration. You might tie that into the same document, but the intent of the safety case is to bring everything together and say, well, this is how we do things here. Okay, and this is why we think it's okay, because we manage this risk like this, we manage this risk like this, we manage this risk. But it's not actually specifically used for managing risk. It's sort of a central place to document how you do all of these things. Okay, I hope that answers your question, Ramesh. So I've got another question about LOPA. Is there different types of LOPA, i.e. using risk graph and then without risk graph? Yes, there are different ways of applying or of identifying safety integrity levels for your facility. And it depends on how your system is set up. So you can use a risk graph, and that's a relatively, it's sort out beforehand. You draw out the different scenarios, and then from there you'll be able to identify the severity levels. So most of the work is done before the workshop. You can use a failure data, which is an order of magnitude failure data, for example, from the CCPS books. And that is looking specifically at a type of calculation. And then you're comparing your target with your calculated value to see if you have any gaps. And that's just going to slightly more granular. Maybe there might be some things which in a risk graph you would have assessed to be a SIL 2, and in a LOPA you might assess to be a SIL 1 with a risk reduction factor of some number, which is not necessarily taking all the way to a SIL 2. And then after that, you can maybe have a look at your a SIL assessment. So having a look at the exact equipment that you will be using and determining whether it is suitable for that purpose, whatever you've identified in the LOPA. That's the final part of that sort of risk management session. Okay, I hope that helped. There are some examples of risk graphs, layers of protection analysis in the IEC 61511 Appendix G. So if you have a look at that, you'll be able to see some examples there. I've got another question here. So is risk matrix specific to an industry and varies by organization to organization, or is it common for all industries, or is there any standard to follow, any guidelines? So there's this standard here, which is risk management and risk assessment. In this, it has some example risk matrices. Let me see if I've got it open here. But the key thing is it doesn't tell you what to put in the different severity categories. Okay. Now, the reason it doesn't tell you is because everybody's risk profile is different. So if you have recently had an incident and the public eye is on you, you may want to be a little bit more risk averse than maybe you were beforehand. And so you may calibrate your risk matrix a little bit differently to allow you to manage your risk more effectively. Okay, but what it does is it gives you a typical 5x5 matrix. And what I would say is make sure that when you're setting up your risk matrix, that you not only have categories to identify the difference between a medical incident, a day away from work, or a fatality, but also have a way of identifying the difference between occupational health incidents and process safety incidents. So if your top category is fatality, single fatality, all of your process safety incidents will fall into that category. And you won't know what the difference is between somebody working at height, which is a typical occupational safety incident, which is managed in a completely different way, to say a process safety incident, which has the potential to kill 10 or more people at your facility. So what I would recommend, that if you are drawing up your risk matrix, if you haven't done so already, make sure your category for severity has one, which allows you to identify the potential for 2 or more or 3 or more fatalities, to allow you to identify the difference between a process safety incident and a personal safety incident. But this document, IEC 31010, can definitely help you set you on the right track for format, etc. I've got a question about the difference between layer of protection analysis and SIL determination. So it depends really on where you're working. So some companies use LOPA and SIL determination interchangeably. And other companies use layer of protection analysis as that first analysis after your main Hazop to identify which instruments need safety integrity levels. And then they do a second workshop, which they call a SIL determination workshop, which is then looking in a little bit more granularity. For example, you might have identified a valve closing spuriously as a cause. And in the in your layer of protection analysis, you assumed the default value of 1 in 10 times or 1 in 100 times, whatever you did. But now actually you've purchased your valve and you realize that you've purchased a really reliable valve and it has the failure frequency data on it. And so therefore you're going to revisit your layer of protection analysis and put in the values specific for your equipment that you've purchased. And then this determines the final SIL level that you need for your instrumentation. However, with this approach, I would be very careful, assuming that the manufacturer data is correct, because quite often what happens in the field is that you have a failure, and so what you do is you just replace that instrument. You don't actually go back and tell the manufacturer that this thing failed in this way. And so therefore the manufacturer's data is typically based on what they've done in their tests in the run up to this. Whereas if you're using if you're using the standard sort of industry data, that's based on industrial failures. Sorry, excuse me. And therefore, you might have a more conservative number there. So if you want to refine your layer of protection analysis because you feel that it may be too conservative, you can definitely move forward with this SIL determination once you know your instruments, etc. However, just step with caution so that you're not removing that the layer of protection or the buffer that you've provided in your assessment. You're not removing all of that and eroding the value of your LOPA. So I've got another question here. Are event trees or fault tree analysis of the same importance as LOPA, and would they be conducted around the same stage of the project? So event tree and fault tree analysis is quite time consuming, and it can be done at different levels. So for example, you might look at a specific piece of equipment, for example, a loading arm, and you might do an event tree and fault tree for that. Or you might be looking at, say, a higher level, loss of containment on the facility leading to fire explosion. And then as a result of loss of containment, we could have different steps. So we might be looking at an equipment level or maybe more of a process level and seeing how we could get there. And the event tree and the fault tree analysis, if you're doing it on that sort of higher level, that forms the basis for your bow ties, really. That's what your bow ties are, is a representation of this event tree and fault tree analysis. What I would say is that event trees and fault tree analysis are relatively time consuming. And what we typically do is we use the hazard identification and the Hazop to identify the event side of the event trees. And then for the fault side, that will also come from those two studies, but from the consequence element. And then if we were looking at the likelihood, that will come through from the LOPA. And what we typically do is we do the hazard, the Hazop, the LOPA, and then we convert those high severity scenarios to bow ties, which forms our event and fault tree. If we have some specific piece of equipment on our facility, which we really need to work really well, we may do this event or fault tree analysis for that piece of equipment so that we can see which parts we do, or we might do a failure modes and effects analysis. But typically, we wouldn't do this event and fault tree analysis on its own in a project, and it would depend on if we wanted to build a bow tie or how much we managed to get from our hazard and our Hazop. And specifically, if we have a specific risk that we'll want to manage, maybe it has a high severity, etc., then we would be looking at either event tree or failure modes and effects analysis. Does anybody have any other questions? That was my last question so far. Okay, well, I hope that the session has been helpful so far. I'll give a few more minutes. I'll stay on the line until 7:45. If you have any more questions, feel free to type them in the session. What I have found historically is that people can get confused between hazard identification, risk assessment, and risk management. And that's why it's important sometimes to separate that hazard identification part from your risk assessment. Unless you have somebody who's quite proficient in both, you can put them together in one session. And also when you're doing your hazard, some companies like to do the risk assessment when you're doing the hazard, and other companies like to fall through with the hazard and just do the severity and then do the likelihood afterwards. And you have to follow the processes at your facility, but there are some best practices out there which you can maybe get off the internet or from some international standards. There is a really good risk guide from the Engineering Council, which outlines the important parts of risk management in there. So if you haven't seen that, just go over to the Engineering Council website. It's a really useful document, which I've seen recently. Okay, well, if we haven't got any more questions so far, I'm going to share my screen again, and we'll just discuss what's coming up next. Oh, wait, I have one more question. I'm going to, she just asked if I would show the standard document again. So this is the standard document for risk management and risk assessment, which is IEC 31010, and it was issued in 2019. What I can do is I'll take a note to send out the details of the standard after this. Okay. And the next one is Ankamam, which I've probably pronounced wrong, apologies, has asked for a link for the Engineering Council, which I'll put on as well. Okay. So if there's no other questions, I will just go through what we're coming up with next. So what we're coming up with next, so I'm just going to change that, is we've got Wednesday, the 17th of March. And we're going to be looking at management of change specifically. So we'll cover the different stages of management of change and really the key things that you should be doing at those different stages. And then I'm also going to cover some live examples as well, which is what we typically do in our masterclasses, which people have found very useful. And then the next session, I think, is on the 6th of April. It's the first Wednesday in April. And then that's going to be also on management of change. And the only thing to remember about that one is that that one's going to be happening at 8 a.m. UK time rather than 8 p.m., which is our normal session. Okay, so when the first Wednesday of April will be 8 a.m. and we've got the masterclass happening on the 17th of March. And we're going to be covering management of change. I've put up all the other topics on my website. So if I just bring that up now. And you'll be able to see all the topics that are coming up for until the end of the year. Actually, I've put all the topics up there. So if you go to my website and you go to the store and you go to the masterclasses, all the topics that are coming up are here. So these two have already been. Management of change is our next one. We're going to be covering Hazop, hazard, overpressure, occupied buildings, nitrogen and diesel. And in the nitrogen and diesel ones, we're going to be actually applying all the things that we've learned so far to these hazards, to an example of either storing them or using them for something. So we'll be able to have a look at how we should actually apply all of these things that we've learned, how we could apply those to a real life situation. Okay. So if there's no more questions, so I've got one more question here. So it is very important to conduct a Hazop as soon as possible on any new process. So it definitely is very important to conduct a Hazop as soon as it's possible, because if you leave the Hazop till too late, the design will be too far along that you won't be able to change anything. So if you find a major problem in your design through your Hazop, which is the intent of the Hazop, you might not be able to change it, and therefore you then have to live with it. And so instead of having actions like move the relief valve to upstream of the blockage, you're going to be having actions like locking open the valve, which means that you're building in inherent risk into your facility. You might have actions like increase the pressure rating of the system because it's underrated. If you leave it too late, that system's already going to be purchased. You're then going to be having to manage that overpressure protection instead of having that good action, which could have prevented that scenario in the first place. So making sure that you do the Hazop as soon as you possibly can, but it definitely needs to be done at a time when you still have potential to change something in your design. If you do it too late, i.e. everything's already frozen, you're not going to have time to change, and therefore that risk that you've identified that you could have changed is just going to be inherent in your system. So definitely try to do it early, but if you do it too early, you're going to have too many actions, and that might be then you do a coarse Hazop rather than doing a detailed Hazop, and you come back and do a further detailed Hazop later. So I hope that answered your question there. Got another question. Is there any recommendation framework on how often a Hazop or any assignment should be revisited as the project develops within the early stages? So what I would recommend is that you do a course Hazop on your different options. So you can do an inherently safer design study or a course Hazop, depending on what your company calls it. It's looking at your different options and it's saying, okay, well, if I do option 1, if I do option 2, if I do option 3, and sometimes you can do this really early on and say, okay, well, this is what we need to do. And this might actually help you flesh out different options that you could use, but in a way that identifies the risk associated with using those different options and which one is the inherently safer one. But definitely should do one in the early phase to identify on a process flow diagram perspective what the key process risks are for your facility and whether there's any opportunity to eliminate any hazards by doing some slight design changes. For example, what I mentioned by increasing the pressure rating. Then after that, when your P&IDs are sufficiently mature, you then do your detailed design or your feed Hazop or your early Hazop. And this is looking line by line at your P&IDs. And then once you have finalized your design, you're nearly ready for construction, you do your detailed design Hazop. And this is looking then again line by line. You might do it as a difference to the previous Hazop because you typically freeze your design after your main Hazop, but you might do a brand new Hazop and you might call this your main Hazop. Depends on how you run your process. And then what I would do typically after that is once you've closed out all the Hazop actions, there is a potential that by closing the Hazop actions, you've inadvertently introduced additional risk to your facility without knowing it. So what I would suggest is you come and have a look at like a Hazop review or a gap assessment. When you've closed all your actions out, you have a look to see whether you've introduced any risks you didn't identify before. And that you do just before you finish, just before you start construction. And then typically in an operating facility, you would then revisit your Hazop every 5 years after that. So maybe the first one is a Hazop by difference, and then the second one is a full Hazop, and so on, depending on how good your base Hazop was and how many changes you've had. With regards to a project, if you do a major change on your project, you change the concept, you change pressure rating, etc., you may have to do another Hazop. And this might be a management of change Hazop, so it might not be a full re-Hazop. But if you change things significantly enough, you would want to do a full Hazop again. So the ones that I've mentioned are your typical ones, but you may also want to do additional Hazops, and there may be mini ones. A management of change Hazop may just be looking at 1 or 2 P&IDs, or it may be do the whole thing again, depending on how big the change is to your project. And we'll be covering a little bit of that next time in the management of change. And I'll be covering the difference between managing change during the project and managing change during operations. Okay, well, thank you guys all very much for attending today. I've really enjoyed the session and the great questions. And I look forward to seeing you guys next month, or maybe at one of the masterclasses.